Okay, so guys and girls, this is another maths question. Now, with the maths question, guys, you have to keep revising, keep going through it till tomorrow. Hopefully, you'll get it. You keep practicing, you keep looking over, and it'll get easier the more you look at it. So, here's my question. I just want you to make a note of it. Calculate the percentage by mass. Guys, give yourself a title, percentage by mass, so you don't get confused between the different math skills that you need. Calculate percentage by mass of oxygen in carbon monoxide, carbon dioxide, and potassium nitrate. That's CO, CO2, and KNO3. I'm going to get rid of this. Now, what I want to say first and foremost is that working out the percentage of anything is the same. Okay, so to work out percentage of anything in the world, it's the thing you're interested in, divided by the total, and then brackets, you do this first and then you multiply it by 100, right? So that is literally the principle of percentages. So let's do A. Okay, now to do A, what we're going to need to do first is to work out the total. So A was carbon monoxide. So what's the total mass of carbon monoxide? Well, I've got one carbon and one oxygen. So it's 1 times 12, which is 12, plus 1 times 16, which is 16. So what's 12 at 16? Well, 12 at 16 is going to give you 28. So that's my total. What are we interested in from the question? We're interested in the amount of oxygen. So here's my total. So my total is going at the bottom, 28. What am I interested in? I'm interested in the oxygen. Well, my total oxygen is 1 times 16, which is 16. Put that in your brackets, multiply that by 100, and then that'll be your answer, which I haven't got. Silly me. So let's do it together. It's going to be 16 divided by 28 first. Multiply that by 100, which will give you 57%. Right. So let's do B now. B is going to be CO2. CO2. So first things first, work out the total. I've got one carbon and 2 oxygens. So my total mass is going to be 1 times 12. If you're thinking where did the 12 come from, it's the top number from the periodic table on carbon, plus 2, because I've got 2 lots of oxygen, times 16. Again, the 16 is from the periodic table, it's the top number. So when I add those two together, I'm going to get 44. Right? I'm going to get 44. So that's my total. So my total is going at the bottom. What am I interested in? I'm interested in the amount of oxygen. In this case, I've got 2 times 16 oxygen. So that's going to be 32 divided by 44. Do that first, then multiply it by 100. So let's do that on our calculator. It's going to be 32 divided by 44. Multiply that by 100. So let's times it by 100. Just to show you that it is 72% to the nearest whole number. Right, so that's that done. Now let's do KNO3. So C, it's KNO small 3. So what does this mean? Let's get our total first. I've got 1 potassium, 1 nitrogen, and I've got 3 oxygens. So to work out the total, I need to do 1 times, so that's more potassium first, 39. So potassium is 39 because it's on the periodic table. It's the top number for potassium. Plus 1 times 14. I got the 14 from the periodic table again. Top number for nitrogen. And I've got 3 lots of oxygen. So I'm going to say 3 times 16. Where did the 16 come from? Periodic table. Top number for oxygen. So when I add all of these up, I get 101. So that's my total. So my total is going to go on the bottom. So here's my total. What am I interested in? I'm interested in the oxygen. How many oxygens do I have? It's 3 lots of oxygen. So it's 3 times 16, which is going to be, what's 3 times 16? 6, 12, 8, 18, 8, 1, 3, 48 divided by 101. Do that first, then multiply it by 100 to get your percentage. So let's see the percentage by mass of oxygen in KNO3. So it's 48 divided by 101 and then times by 100, and you got 47%. That's really 47%. Is that okay, guys and girls? It's as simple as that. Let me give you that'll do really. So you can do it for anything, guys. If they want, for example, sodium Na, let me think. If they want it for, let me think of something, NH3. So NH3, and the question was how much percentage by mass is there of hydrogen. You do the same. You got 1 times nitrogen plus 3 lots of hydrogens. That's going to be your total. Then it's going to be 3 lots of hydrogens divided by your total. Okay, exactly the same thing. Doesn't matter what it's for. Right, exactly the same thing. Percentages are always the same thing. Right. So next I'm going to go on to yields. Okay, I'm going to do this in one video because it's quite simple. Now with yield, the yield is what you get out, so what you end up getting. Right, now in a chemical reaction, you want, when you got A plus B, whatever A and B is, you want to get C, right? Now if a chemical reaction, if you can get 100% C, that would be amazing. However, it's not possible, okay? And so this is one of the things that you need to know, is why is it not possible to get 100% yield? So just looking at this equation, we can figure it out, okay? So point number 1 is that not all of the reactants, that's the things that are reacting, not all of the reactants will react, right? So that's point. If not all of it reacts, you're not going to get all the product. B is that you might have waste product. So this is another reason. So we want C, but actually we end up getting D. So waste products are formed. Right. So also before you even start the reaction, while you're getting the materials in, you might have loss of materials. So that's even before you start the reaction of reactants. So you might lose some of A, some of B, while you're not going to get your full reaction then. And so those are the real main points about why yield is never 100%. Okay, this is not possible. So now let's look at the maths. So you need to be aware of that, guys. So let's look at the maths of this now. It's very, very easy. Again, what they're gonna say to you is that you've got a yield. Let's say your theoretical yield. So in theory, you're going to make 60 grams of a product, but in reality you only get 20 grams. So the question is, what is the percentage yield? Well, it's the thing that you're interested in, which is the reality. So in reality I got the 20 grams divided by your total in theory, which is 1/3, which is 33%. Now obviously you have to multiply this by 100 to get it into a percent, which is 33%. Let's go through another example. So in theory, you've got something that should give you 250 grams of your product. However, in reality, it gives you only 100 grams. What is the percentage yield that you got? Well, it's the thing that you're interested in, which is the reality, divided by your 250 grams, and then you're gonna times that by 100. So it's going to be 10/25, which is, let's see, so it's 100 divided by 250 equals, and times that by 100, which is 40%. Do you see how simple that is, guys and girls? Very, very simple. I'm going to leave you with a question, and then I'm just going to disappear. So in theory, you're supposed to have a product comprising of 6. Now guys, I just want to point out before I say it can be grams, it can be kilograms, it can be tons, it doesn't matter. It's a ratio. It's a ratio. It doesn't matter. So if I say 6 tons and in reality you only get 2.5 tons, right? these units will cancel out, so it really doesn't matter. It's exactly the same thing. It's going to be 6 tons divided by 2.5 tons, and that'll give you, no it's not, don't be silly, it's going to be your reality, which is 2.5 tons divided by your total, which you should have got 6 tons, and then multiply by 100, and then it's exactly the same thing. So let me give you a question and leave you with this. So in theory you should have got 45 tons, but in reality you only got 16 tons. Calculate the percentage yield that you actually got. Exactly the same way. Look back if you can't figure it out. And that covers that. So I must stop this video.